Okay, guys, so obviously we left off where we had factored out the x plus 1 because that was a common term, and we were left with x squared minus 4. The x squared minus 4, again, came from what was left over in those two terms when I factored out the x plus 1. Okay, so then from there you have to look at what you have left, and this is where step 4 comes in. And step 4 is to factor further if possible. So you look at what's left. X plus 1 can't factor, but x squared minus 4, that's a dot. That's a difference of two squares. So I can factor that out. So I still have my x plus 1, and I can factor x squared minus 4 to be x plus 2 times x minus 2. And that would be our fully factored out answer. Again, that won't always happen, but you always want to make sure that you are checking to make sure that there is not something else that can be factored further after you've done your grouping method. Okay? So now let's get into some examples. Hopefully the more we kind of practice this, the more it will start to make sense. So first thing that we do is we create our groups. Again, you always include the sign in that second set of parentheses. So we're going to include the negative with the 9. So I'm going to go ahead and factor out the GCF from each parenthesis. So x cubed and x squared, I can take an x squared out and I would be left with x minus 1. In the next set of parentheses, I can take out a negative 9 and I would be left with x minus 1. Now, if you didn't think to take out a negative 9 and you only took out a positive 9, you would notice that what you have inside the parentheses would not end up being the same, and then you wouldn't be able to continue simplifying. The entire purpose when we factor out the GCF, what I just did in green, was so that we end up with the same term inside the parentheses. Because if I end up with the same thing inside the parentheses, I can factor out that set, that x minus 1 in this case. If I don't have the same thing, I can't do anything any past that, right? So I need to make sure that I have the same thing inside the parentheses. Once I do that, I can factor that out. So I can factor out the x minus 1, and I would be left with x squared minus 9. Okay? From there, I look to see, can I factor anything further? And I can factor this x squared minus 9. So I keep that x minus 1. Then I would have x plus 3 times x minus 3. And since it's multiplication, technically the order in which you put those three sets of parentheses would not matter. You would still end up with the same answer in the end. If you ever weren't sure if you did that correctly, you could go ahead and FOIL the first two sets, and then you could go ahead and FOIL that into the last one as well to make sure you get back to what you had from the beginning. Okay, so let's go ahead and let's look at number 2. First thing I do is I group. Whether it's addition or subtraction, remember you always put the sign in with the parentheses. That's step 1. Step 2 is to factor out a GCF from each set of parentheses. So in this case, I can take a 3 out and I can take an x squared out. So here I would just be left with x minus 5, because 15x squared divided by 3x squared would leave me with 5. Then here I can take out a positive 4, and I would be left with x minus 5. Again, the whole point of doing this is that I end up with the same thing inside the parentheses. I can factor out my parentheses, I can take out x minus 5, and I would be left with 3x squared plus 4. If you look at that, you cannot factor anything further, so that would actually be our final answer for this problem. Okay, let's move on to number 3. And hopefully the more you're seeing this, the more it is starting to make sense. First step is to group. Second step, factor out the GCF. The largest thing I can take out of the first set of parentheses is an x cubed. I would be left with x plus 2. Second set of parentheses, there is actually nothing that goes into x and 2 other than 1. And I know before we were saying you don't have to factor out 1. In this case, you actually do want to factor out that 1. So I'm going to factor out a positive 1, and I'm still just going to be left with x plus 2, which is good because that's what you want to have. You want to have the same thing in the parentheses, but you need to make sure that you still are taking something out, even if it's just 1. So then when I go ahead and factor out my parentheses, my x plus 2, and I take those out, I would just be left with x cubed plus 1. That's all I can do. I can't factor that any farther, So then that would be my final answer. Let's look at number 4. Again, hopefully the more we're doing this, the more it's starting to make sense. Number 4, I need to group first. Always make sure you include that negative. Then I need to take a GCF out of each set of parentheses. So 5x to the third minus 40x squared, I can take a 5 and an x squared out. I'd be left with x minus 8. In the next set of parentheses, I have negative x plus 8. That is not the same as x minus 8. But if I factor out a negative 1, that would make this positive x and would make the 8 negative. Now I would end up with the same thing in both sets of parentheses, which is good because now I can factor that out. So I would factor out x minus 8, and I would be left with 5x squared minus 1. When you go to look to see if you can factor anything further, 1 is a perfect square, x squared is a perfect square, but since 5 is not, that is not a dots problem. So that would actually be my final answer. Moving on to number 5. Again, start by grouping. Group my two sets here. Then I see what's the largest GCF I can take out of x to the 5th plus x to the 4th? It's x to the 4th, and I would be left with x plus 1. Then I look to see negative 16x minus 16. I can take a negative 16 out, and I would be left with x plus 1. So then from there, I can go ahead, since I have the same thing inside the parentheses, I can factor out an x plus 1. So I can take x plus 1 out, and I would be left with x to the 4th minus 16. Then you look to see if you can factor any further. I can factor x to the 4th minus 16. That's a dots problem. So then I would have x plus 1 times x squared plus 4 times x squared minus 4. That's the dots. So this right here came from this part. But then I have to look again. X squared plus 4 I can't factor. We've already talked about that. But x squared minus 4 is actually another dots, so I can do it a second time. So x plus 1 times x squared plus 4 times x plus 2 times x minus 2. That would then be my final answer. It's not always the prettiest. It's very long in this case, the answer, but that is how I would split it up, simplify, factor it as much as possible. You might be able to do it a couple times. So now let's go ahead and let's look at our last problem. So I'm going to group my two sets first. 2x to the third minus 5x squared. The largest number or term that I can take out is x squared. I can't take a number out because 2 and 5 don't have any common factors. So I would be left with 2x minus 5. Look at the second set of parentheses. The GCF that I could take out of there is positive 9. That's the largest number that goes into both of those. I'd be left with 2x minus 5. Again, that's good because you always want to have the same thing inside the parentheses. That way you can factor it out. So I can factor out a 2x minus 5, and I would be left with x squared plus 9. Since it's addition, that is not a dots problem, so that would be my final answer. Okay, there's nothing more that I can do for that problem. So that was grouping, and I understand you guys might still have some questions. You might not be 100% sure of things, but hopefully as you practice this more and as we go through the live session, it'll start to make a little more sense. So at this point, now that you are done taking the notes, you can kind of digest this for a little bit, and then you can get ready to meet with me soon in the live session. Okay, I'll talk to you soon. Bye.